Reconstruct the original circle from the smallest preserved arc. A fragment may be incomplete, but its geometry still speaks. From a single photograph or a traced curve, DiaSnap helps reveal the true diameter hidden within the surviving arc. The workflow begins by uploading a photograph of the fragment into DiaSnap. The image should clearly show the preserved curved edge of the object, together with a visible scale reference placed in the same plane as the fragment. This is important. If the scale and the fragment are not on the same plane, the measurement may become inaccurate. Supported image formats may include common file types such as JPG, PNG, and TIFF, depending on the platform setup. You can also take a photo directly, but the image must be suitable for measurement. For the best results, use a clear scale line for calibration. Make sure the lighting is even and the image is sharply focused. This is especially important when working with faint pencil-drawn arcs or lightly visible edges. The preserved arc and the scale line should both be visible and clearly readable. Once the image is loaded, it appears in the main workspace. You can zoom in and out using the mouse scroll wheel. You can also pan across the image by holding the Control key while left-clicking and dragging. This allows you to inspect the fragment more precisely and position the image comfortably before starting the measurement process. If there is too much empty space around the arc, you can crop the image to focus only on the relevant area. On mobile and tablet devices, you can use 2 fingers to zoom in and out. You can drag with 1 finger to move the view, and tap once to select points. This makes the workflow usable both on desktop and mobile devices. To produce accurate real-world measurements, you first need to calibrate the scale. Select 2 known points on the visible scale object in the image. After marking these 2 points, enter the actual distance between them. For example, this may be 50 mm or 5 cm. If needed, you can reset the selected points by clicking Undo. Once the 2 points and their real measurement are defined, click Confirm Scale. DiaSnap then calculates the pixel-to-real size ratio and stores this calibration for the current analysis. This step is essential because the diameter calculation depends directly on the accuracy of the scale calibration. A weak calibration will produce a weak result. So the scale should be clear, sharp, and placed correctly beside the fragment. After calibration, you can identify the preserved curved edge of the object. Click Start Manual 3-point mode. Then place 3 points along the visible arc. Ideally, choose 1 point near the beginning of the curve, 1 point near the middle, and 1 point near the end. The more accurately these points represent the preserved arc, the more reliable the diameter reconstruction will be. This step is especially important when the preserved arc is short. A very small arc can still produce a useful result, but it must be selected carefully. The geometry may still speak, but only if the input points are chosen with precision. Once the curved edge has been selected, DiaSnap mathematically fits the best possible circle to the chosen arc. Based on this reconstructed circle, the application calculates the estimated original diameter of the object. DiaSnap can also estimate how much of the original circumference is preserved. This gives you not only the diameter, but also a better understanding of the fragment's relationship to the original complete form. For pottery rims, bases, and other curved archaeological objects, this can be extremely useful for documentation, comparison, typology, and publication. After the calculation, the reconstructed circle is displayed as an overlay on top of the image. This allows you to visually check whether the proposed circle fits the preserved fragment correctly. You can inspect the result and decide whether the selected arc points were accurate. If the circle does not match the visible curve well, you can adjust the selected points or repeat the arc definition. This visual review is important. The software can calculate the result, but the researcher must still judge whether the input and output make sense. Good documentation depends on both mathematical calculation and critical visual control.